Welcome to JavaSpace. In this video, I'm going to show you the traditional approach of solving the use case or the problem I showed you in the previous video. So we are saying Bob wants to transfer money from his account to Alice's account. And so we saw all these method calls that needs to happen, or which obviously translates to SQL queries at low level. So now we are saying in the traditional approach, each method call establishes its own connection and it begins a transaction. It executes a query. Then it commits a transaction or it holds back a transaction. So we see that if you are doing all that for each method call, clearly that's not an optimal way of solving that problem. So we see that in this case, each method call is an independent transaction, whereas they have to be treated as a single unit of work because the debiting of the amount in Bob's account is highly dependent also on, the updating of Alice's total balance is highly dependent on the debiting of that amount in Bob's account and updating Bob's total balance. So what does that mean? It means that if this method call fails, then we must unchange or undo whatever we have done in method 2 and method 3. But if you are treating these method calls as independent transactions, it becomes difficult to do so. Well, it's not difficult. You might have to write some logic to track whether the previous calls were successful or not. But then, even in that case, it's still not an optimal way of solving the problem. So what should be done is all these method calls must be treated as a single unit of work. And in that way, it means they execute in one transaction, which means we will establish one connection, begin a transaction, and execute all those queries in that particular transaction. And then in that case, if one of them fails, it's even easy because the rollback would happen in one transactional context, as if I may put it like that. But if one method fails in a situation where each method is treated as an individual transaction, it becomes difficult to actually manage that particular transaction in another transaction. So there are two scenarios here. If you are using connection pooling, it would mean that in a traditional approach, for each method call, if you are using a transaction pooling, it would mean that for each method call, you will request a connection from the pool, connection pool, for each method call. And then when you are done, you will close, which means the connection will be sent back to the pool. If you want another, if you come to method 2, you request for another connection object. You do whatever you do, the connection goes back to the pool. You see, obviously, that is not a good way. If you are not in a pooling scenario, that means you don't create connections in advance. This is even the worst case scenario because it would mean that for each method call, you have to make a call to a database management system to establish a connection first. Then do whatever you want to do. Close that connection. Make another request to a DBMS to establish a call to them. And then do whatever you do until you are complete with your method call, your whole transfer of money from one account to another. So we see that the traditional approach is not the best way of solving that use case. So in the next video, I'm going to show you the modern approach, or you can also call it the transactionality approach.